Hello, welcome once again to Mathematics Meal. I believe you are enjoying your day. I believe you are having a lovely moment. In all your lovely moments, please don't forget mathematics. Thank you. All right, we want to see how far we can go today on solving questions involving number base. We have solved some examples in our previous video. Now we want to solve example 4 and example 5. Then we'll give you some takeaway questions so that you enjoy yourself. All right. Still the same procedure. I believe you have mastered the steps. So let's look at solution to the first question. That's example 4. We say to solve equations involving number base. What do? The first step is to take note of the equation. So this is what we want to solve. Now, 5, 2 in base x minus 2, 4 in base x equals 2, 5 in base x. Okay? That's the question we want to solve. So we have taken notes. The next step, they say express all the numbers in base 10. Now, this is not in base 10, this is not in base 10, this is not in base 10. They are in base x. So we need to express them in base 10. You still remember the method we use in expressing numbers in base 10. In case you have forgotten, please visit our video where we treated how to change numbers from other bases to what? To base 10. So we do this. 5 times x raised to power 1 plus 2 times x raised to power 0 minus 2 times x raised to power 1 plus 4 times x raised to power 0 equals 2 times x raised to power 1 plus 5 times x raised to power 0. Now, one of the errors that students can commit in the case of trying to solve this problem, when they try to solve this problem, is failure to put this bracket. I know some people will just write this 5 times x raised to power 1 plus 2 times x raised to power 0 minus 2 times x raised to power 1 plus 4 times x raised to power 0. Now, this is wrong because this negative sign is supposed to affect these 2 digits. So, in order to ensure that it affects these 2 digits, that's why you have to put this in bracket. Very important. Very important, because by the time you expand, you notice that this will change this positive sign to negative. Please take note of that. Alright, so we continue here. 5 times x plus 2 times 1, because x raised to power 0 is 1, x raised to power 1 is x, minus 2 times x plus 4 times 1 equals 2 times x plus 5 times 1. Thus, x raised to power x is 1, x raised to power 0 is that. We simplify further. That's the third step. Remember the third step in that in our last video. That's the steps involved in solving equations. So we look at this. We have 5x plus 2. 5 times this is 5x, 2 times this is 2, minus 2x plus 4 is equal to 2x plus 5. Okay? We can now write 5x plus 2, then this will open this bracket. We have minus 2x minus 4 is equal to 2x plus what? 5. Okay? We move further. 5x minus 2x plus 2 minus 4. These two are like terms. So equals 2x plus 5. 5x minus 2x will give me what? 3x. Plus 2 minus 4 will give me minus 2. Yeah, you need to be careful with signs. So we have 2x plus 5. Then we gather like terms. Minus 2 will move here. 2x will come here. So we have 3x minus 2x. I have 5 here. This will give me plus 2. 3x minus 2x is x. And 5 plus 2 is what? Is 7. Wow. That's beautiful. That's beautiful. So the answer to this is that x is equal to what? 7. So if x is 7, if this is these numbers are in base 7. That's the only time 5, 2 in base 7 minus 2, 4 in base 7 will give us 2, 5 in base 7. And if actually you carry that out, you have 5, 2 in base 7, 2, 4 in base 7. Let's see whether it will give us 2, 5 in base 7. So 2 cannot subtract this, so we take 1 here and call it 7 because we are operating this in base 7. 7 plus 2 is 9. 9 minus this is 5. Remaining 4 here, 4 minus this is 2. So you see, that's correct, 2, 5 in base 7. Yeah, we have all these videos. Just take our time to look at them, but whether it is addition of numbers in other bases, subtraction of numbers in other bases, multiplication of numbers in other bases, and so on. Wow, we need to continue. We have one more question to consider, and then we'll be done. That's example 5 now. Question 5. So we'll do that. Question 5. We have the solution to this. We have 142 base n is 47 in base 10. Okay, this is already in base 10, so we don't have problem trying to handle that because it's already in base 10. So we have taken note of this. Express both sides in base 10. This is untouchable because it's in base 10 already, so we touch this one. Our normal method 0, 1, 2. So 1 times n raised to power 2 plus 4 times n raised to power 1 plus 2 times n raised to power 0 equals 47. That's what we'll have. So that will give me 1 times this is n squared, 4 times this is 4n, 2 times this will give me, okay, let's still break it down further. 1 times n squared plus 4 times n raised to power 1 is n plus 2 times n raised to power 0, 1. Let's just follow all the steps. 1 times this now is n squared, 4 times this is 4n, 2 times 1 is 2, and we have 47. Now this equation is not like the ones we have been forming previously. All the equations we have solved so far, they are all linear equations, but now we have a power of 2. So this equation is quadratic in nature. So what do? We know how we express quadratic equation. Plus 2 minus 47 equals 0. Okay, I just brought this here. If you simplify further, you have n squared plus 4n plus 2 minus 47 will give me minus 45 equals 0. Solution to quadratic equation, we have 4 known solutions, known method, common method that we use. One of them is the factorization, the completing the square, the use of general formula, or the graphical method. Wow, we cannot start plotting graph now. We cannot. We'll find the roots of this equation. We can use completing the square, we can use the general formula, or we can use factorization. I want to factorize. Remember how we factorize. Multiply the first and the last term. That will give me minus 45n squared. So, do we have numbers that we can multiply to give us 45? Minus 45. 2 numbers, 2 factors that we can multiply to give us this. And when we add them, we have the number in the middle. That's the coefficient of n. Do we have? You still remember this? We are not treating quadratic equation. In case you want to know how to factorize quadratic equation, we have a video on quadratic equation which you would like to watch also. Okay, so we move straight. I'm not treating this, but by the time you factorize, the numbers will be 9 and the 5. The first sign will obviously go to the bigger number. The product of the 2 signs will go to the smaller number, so we have minus 5. Because when you say plus 9 minus 5, you will have 4. And when you say plus 9 times minus 5, you will have minus 45. So these 2 numbers will replace this. Yes, we will replace that. So we have n squared plus 9 n minus 5n. That's this and this. Minus 45 will give us 0. So we factorize by grouping n bracket n plus 9. What is common here is n, so I factorize this. these two groups, factorize this also. What is common here is minus 5. When minus 5 divide minus 5n, I will have n. And when minus 5 divides 45, divides minus 45, minus dividing this is plus, and 5 divided this is 9. We know that when you factorize by grouping at this stage, the two terms in the bracket must be the same. So let's factor that. We have n plus 9. When I factor n plus 9, I remove n plus 9. I've removed n plus 9. This n plus 9, I will be left with n minus 5. So I have n minus 5 plus 0. So equating each factor to what? To 0. N plus 9 is 0, or n minus 5 equals 0. So n will give me minus 9, or n will give me 5. That's when n moves here. Okay, let's complete it. 0 minus 9 minus 9. 0 plus 5 when this comes here, or n equals 5. Okay. So which one is the value? Is it 9? Is it minus 9 or 5? You remember that at the beginning, when we started this, we said that the base of a number cannot be negative. So the actual value, n is equal to 5, since the base will not be a negative number. So we don't have two answers here. What we have is just one answer. That's 5. Because of what? The base will not be a negative number. All right. Let's have our takeaway question. I believe that what we have done so far is very clear. In case you still have difficulties trying to solve equations involving number base, you can contact us on our Facebook. You can also contact us through our email. You can also contact us through WhatsApp. Our numbers are available. Okay, quickly, takeaway questions. Oh, beautiful. Let's have our takeaway question. 1. If 2, 3 in base x plus 1, 0, 1 in base x is equal to 1, 3, 0 in base 4, find x. 2. If 5, 5 in base x plus 5, 2 in base x is 7, 7 in base 10, find x. 3. Given that 6 arrow 7 in base 8 is 5, 1, 1 in base 9, find r. Question 4. Let's look at question 4. If 1p 14 in base 5 is 184 in base 10, find p. And finally, let's cause a little problem here. Okay, it's not a problem, none of them is a problem. Let's just say find the value of x. It's very simple, remind me. Find the value of x for which 312 in base 4 plus 52 in base x is 96 in base 10. I'm tempted to make this question to be 6 in number. Yes, I'm tempted to do that, and I'm going to do just that. Going to do just that so that you have a lot of things to enjoy. So if 110 in base x is equal to 40 in base 5. Find x. Wow, that's a meal. You can divide it into breakfast, lunch, and what? And dinner. Yeah, you can take 2 in the morning, that's your breakfast. You take 2 in the afternoon, that's your lunch. You take 2 at night, that's your dinner. Don't mind me. All right, I believe that the concept of number base is very clear to you because this is the last aspect at this level. Yes, at this level, this is the last aspect of number base. Although, when you want to do programming now, you now begin to look at how to apply the binary numbers in doing that. But for the basis of mathematics and the level we are operating on, this is the last aspect of number base where we are expected to cover. And that's equations involving number base. Thank you for following us till now. Until we come your way next time, continue to enjoy our meal. The next ball that we are going to roll out is going to be on modular arithmetic. You will enjoy it. God bless you. I love you.